Well, welcome all to this talk to the Utah Alumni Association. I'm Suresh Venkatasubramanian. I'm a professor at the School of Computing, and I'm glad to have this chance to talk with all of you about some exciting new developments in computer science that I've been involved with now for a number of years, and the potential it has for impacting, quite frankly, how our society looks over the next 20, 30 years. So the talk, of course, is, as you see, the social impact of machine learning in society. And to sort of motivate what's really going on here, let me just sort of walk you through a number of issues that come up here. So the topic we're going to be talking about, broadly speaking, can be considered automated decision making. So what is automated decision making? So it's often as simple as when you use Spotify, what does Spotify recommend to you as the next song you should listen to or the next playlist you should look at? Right? It's the system, an algorithmic system, looks at your preferences, looks at other people's preferences, and makes some decision, hence the term decision, in an automated way about what it thinks you might like to see, and it makes a recommendation. And of course, this is not just Spotify. Nowadays, of course, we spend a lot of time on Netflix and other streaming services, and they are also very good at promoting content that they think you might like. Of course, their incentives here are not always what they think you might like, but what they think they might be able to push to you. But that's a different story. So they have all these recommendations. And it's not just at Netflix. If you're sitting at home trying to buy things where you don't want to go outside, you're going to Amazon to buy stuff. And these have been going on for a while, and you may not think twice about the recommendations. You might find them a little odd from time to time. But apart from that, they don't materially affect your life in a way that you would consider significant. However, there are many other places where the same exact machinery, the same technology is being used in a way that is far more significant. For example, at many universities, like the University of Utah, various data analytics methods are used to decide, or to at least to make suggestions or recommendations about who gets admitted to the university, based on things like, who's likely to not drop out of the program, who's likely to survive through the first couple of years, who's likely to take a long time. And maybe who will be successful as alumni and bring fame and recognition to the university. So there's a bunch of different considerations involved with that, and that's something that many other universities are doing now. There are we've had credit scoring schemes for a long time, but many of these credit scoring systems, they now work on small businesses. They might look at the social media profile or Yelp profile of a small business and make advisements to banks as to whether to give them loans, again, based on various kind of automated systems. There are companies based in Utah itself, HireVue is one of them, that, among other things, provides algorithmic decision assistance to managers deciding, how an interview goes and whether the person gave good answers to the interview, what aspects of their personality come out from the video call. And this is happening right now. Another company that you may have heard of a lot of recently is Banjo. They do many things, but among the things they do is do analytics based on looking at different streams of event information coming in, trying to do alerts to first responders, police, firemen, and so on. And at the national level, international level, you've heard of companies like Palantir, which have been involved with all kinds of automated systems to do surveillance, to do monitoring, to frankly do all kinds of many kind of things that start bringing up larger questions about the way we work with these automated systems in society. You may have heard of the Chinese social credit score. Of course, there are social credit systems that are working all across the world and not just in China to make assessments about people's fitness for credit or for loans or for other things based on factors that include, up to a point, behavioral factors and things that you can observe from things like social media. And so one of the things we've realized is that when we start introducing automated systems into places that are people-facing, into societal settings, right? Not just local settings like Spotify, Netflix, or Amazon, but settings that affect every aspect of life. And truthfully, these systems do affect every aspect of your life now. We have to then think more deeply about issues of how these systems are working. Are they working in a way that is transparent to us and accountable? Do they create more problems than they solve? And these are big issues that we're only now beginning to surface. So in a kind of a rip from the headline story, an article from ProPublica some time ago, of course, everything pre-COVID to me feels like a million years ago, but let's say only 500,000 years ago. School, in response to mass shootings, schools are installing microphones equipped with algorithms The claim is that by using these microphones, you can detect high levels of stress to intervene before violence erupts. Personally, I'm somewhat skeptical about the effectiveness of these approaches. Nevertheless, they're being deployed. Last Halloween, there was a lot of discussion about this, and this is happening more and more. The Ring sort of doorbell you bring with the camera, transmits a lot of the data it gets to local law enforcement, or cameras being mounted on corner stores transmit data to via analytics to systems that can try and see whether there are threats being perceived. So there's an increased amount of surveillance accompanied by the use of AI to analyze the surveillance streams that are coming in. And as I mentioned, insurance companies are debating whether they should be able to be allowed to ask for your Facebook profile when they decide whether you should get insurance, life insurance or car insurance or whatever, to see if there are things in your social media profile or your presence online that indicate your level of risk. And of course, I've already mentioned China's social credit system. And while I would say the hype or the dystopian hype around the system is probably more than is warranted, it is potentially quite intimidating as well. And a couple of things that have happened is that because of the sort of rapid fire, and I used to be able to do this like once every 2 days. Again, in the pre-COVID era, there'll be another story coming about the misuse of technology in these contexts. These come out all the time, and it creates a level of mistrust with technology in general, right? And we can see that in the COVID area. We see mistrust and inequality reflected through COVID-19 sort of situations, things about contact tracing apps, right? So a lot of discussion right now, for example, should we build contact tracing apps that people download, like the one in Utah that we have called Healthy Together, to be able to keep track of where infections might be happening? There's a clear public health argument in favor of this, but there's also a privacy problem associated with it. And there's, again, a trade-off way to think about, how are we going to get the public to adopt this? Do the public trust that systems like this will be used and not misused for the purposes, and so on? We see that biases in society influence the deployment of technology. So we often think of technology as something that is as a leveler, as a great leveler, as an equalizer, as a way to improve inequality. But in fact, often you see that health, various kinds of systems that we put in place, even technologically advanced systems, do not actually equalize inequality within the country, but they actually amplify the biases that already exist. And this is even true right now. Again, this is a story from ProPublica about how the COVID-19 pandemic, and in fact the fact that healthcare has disparate sort of effects across different communities, tends to mean that people in different communities are suffering and dying, in fact, at very different rates. Now, I'm a computer scientist, right? I study computer science, I study data science for a living. It seems odd to be concerned about this. But the truth of the matter is that as we put more and more technology into the public sphere, we cannot help but have to reckon with the challenges that come from the way technology collides with society. And that's sort of where my work lives. And so one of the new areas that's come up is an area called algorithmic fairness, which is, it started off in some ways inside computing, but it's become a much broader discipline that I will outline, which basically asks the question of, can you design decision-making systems that are not unfair, that are fair in some sense of the word? And again, that's something that we have to unpack, like that are able to, that improve issues of inequality in our society, that are able to do better than what we've done before, that lead us to a better future, a more equitable future. Can we do that? And what does it mean to design these systems from a technical point of view? So this means many things, right? It means we have to define what it even means for a system to be fair. And this brings us into all kinds of discussions that touch on work from political science, from economics, from sociology. What does it mean to have equality among groups? What does it mean to have something like demographic parity, where you have some outcome that is equalized, as is often enshrined in US law? What does it mean to have different kinds of fairness in how we represent data and how we run data through automated systems? That might be a whole pipeline of decision-making systems, right? If you talk about the pipeline in technology, for example, and the concern that we don't have enough women and underrepresented groups in computing, well, is this a point where we should intervene at the K through 12 level, at the undergraduate level, at the graduate level, at the higher level? These are all questions that we as computer science professors are trying to answer right now as part of our own work, but also as a scholarly endeavor, bring up an interesting point of how do you intervene in a system to make sure that overall you get what you need out of This also touches on infrastructure. If we want to build systems that are fair, how do we instrument the systems? This touches on all aspects of CS, things like data management systems, machine learning theory, how we interact with humans and computers, human-computer interaction. How do we visualize this data? There's almost virtually, maybe architecture not so much, but virtually every area of computer science has now been touched by these questions and is now being asked to reframe some of the ways it thinks about its own subdiscipline in the light of this larger societal imperative around what we do with technology. Once we deploy technology, though, it's not enough just to put it out there. As a point of principled governance, we want to say that we want to check that our systems work the way they should, right? If we put out a new system, and this has happened, for example, in criminal justice in Utah and other states, sort of the criminal justice system is putting out these algorithms to essentially assess whether people should be released pre-trial without bail. And there's a whole other issue there that I don't want to get to here. But from a technical point of view, if you claim you're putting out a system that is doing a good job, how do you know? How do you check? Doesn't the public have the right to know? How do you build in an auditing system and accountability system to make sure that our systems are doing what they claim to do? Because after all, we must trust, but we must also verify. Once we do that, we start getting to much thornier issues of what does it even mean for a system to be fair? And this touches on issues in philosophy and in ethics, and I guess, like I said, in political science. What does it mean to capture ideas of non-discrimination or procedural fairness or individual agency and dignity, privacy? How do we incorporate these values that we have in society into the technical systems that we build? And again, this is a new discussion. For a long time, we felt technology was value neutral, that we could just put out a piece of code out there and it just was a piece of code. That turns out to not be the case, because the way, especially with machine learning, code draws on data. Data comes from society. So the code essentially absorbs the biases and the perspectives of society through the data it's trained on. And so we have to be much more explicit about thinking about the values we want to encode in our systems to make sure that we don't encode values that we don't really agree with as a society. So sometimes I like to call myself a computational philosopher sometimes, because it feels like often that's what I'm doing, trying to translate philosophy into computation so that algorithms can speak it. And of course, these systems that we build aren't being built in a vacuum. They sort of are, as I said, they refract through fault lines in society of race, gender, class, disabilities. And this is just in the US, of course. In other countries and other cultures, things work very differently. And these have to be reckoned with. And if you want to implement any of these systems, you need law, you need legal frameworks, you need policy recommendations. We have to know how to compromise, how to make sure that what we build or what we propose to build is effective, can be verified, achieve some balance between all the conflicting goals that we have, and isn't sort of too idealistic about it. So there's a trade-off there. And then finally, all of what we're doing with this kind of analysis applies both to systems we want to build, as well as the vast automation infrastructure that already exists. Right? So we're not going to rip everything apart and start from scratch. We want to incrementally improve and update systems we have. So then whatever we want to do has to apply to both the new things we build from a blank slate, as well as things that we already have in place. And this is an ongoing reflective process for those of you who are familiar with the social sciences. This will be a familiar thing. This is less familiar maybe in the computer sciences, where we don't often question the frames of reference we work with. But that's also very important here, because not only does it require us to do this reflective process to understand whether technology is actually improving a situation or making it worse, it also points the way to better tech we can design if we just ask the questions in a slightly different way than we're asking them right now. So that's both an interesting sort of novel challenge within computer science, but it's a way to have a larger discussion with other disciplines on campus and across the world that think about this topic. So this is the big picture that I was sort of wanted to have you sort of stare at for a little bit. And again, as I mentioned, I'm happy to take questions. You can in the chat channel or whichever way you want to do it, and I can stop and answer those, and I'm happy to keep going on, and we can do more Q&A at the end. But I do want to reflect on how we've gone from maybe a very narrow concept of designing machine learning system to do predictions to a much larger integrated framework to think about this. And what I want to do next is give you some examples of what happens when you think about this integrated framework of thinking about technology and society, and what kinds of questions come up. This will be examples drawn both from my own research and from other people's research in this area. And then once I do that, I will then move on to what it means to how we educate students, right? I'm a professor, I teach classes, I want to make sure my students understand a lot of these issues. How do we teach them to think about this? So that's going to be the next two parts of my talk, focusing on specific questions here and then focusing on the educational imperative in how we talk about this. Okay. All right. So if you think of this big system, the first thing I mentioned to you was this issue of modeling and infrastructure. What does it mean to design a system that's fair? So, I'm going to give you a very brief sort of overview of what a machine learning task looks like. This is the only part there will be sort of a lot of notation. If that's something that you're not, comfortable with, but I'll explain what I'm talking about. So think of the most simple kind of thing you might want to do with a decision system that's automated. You want to do some kind of binary classification. What does that mean? You have people, you collect data on people, you put them into some kind of black box or gray box, and then out comes some kind of sorting or decision process. You in, you out, and so on. Right? This could be an example of, yes, you get a loan, or no, you don't. Yes, you get go to the next stage of the interviews, or no, you don't. Yes, you get admission to the university, and no, you don't. Or it could even be, yes, you get you get a loan, but at this rate, you get a loan, but this at the other rate. In general, in machine learning, a lot of problems can be abstracted out as some kind of what is called a binary, because there are two outcomes, a binary classification task. You classify into two groups. And there's some complicated process by which this works on the inside of the black box. So this is the only part where there'll be sort of some jargon, but I'll try to unpack the jargon so it doesn't look too sort of complicated. Basically, in most problems in machine learning, you're given some data. You're given some data and you're given sort of the right answers for some data. This is called your training set. So you might say, here is a list of all the people we admitted to the U in the last 10 years with relevant information about them, their GPA, their high school, transcript, and other information. And this is an information saying what they did. Like, so the different measures of success, right? Did they finish the program? Did they finish the first year of the program? How long do they take to finish the program, and so on? And once you have this training data, what you want to build, or what is people would like to build, is some kind of predictor, this function f, that says, I will predict what is going to happen to a new person, or I'll attempt to predict what might happen to a new person when they get put into the system, when a new person applies to the university. And so when we think of such a system, we think of all the features describing an individual and the outcome. Some of these features, though, are features that we are concerned about, in that we don't want to discriminate based on features. And we often call them protected features. And for example, this might be, well, we don't want to have different answers based on someone's gender, or based on someone's race, or based on someone's religion, or based on someone's economic status. These are things we feel, as a value, and I emphasize the value here, as a value, we think these should not be part of our decision-making process, or maybe as a matter of law, they should be not part of our decision-making process. How do we make sure that our decision system is not affected by these features? And so you can express the outcome of the decision, the fairness, as a function of these things. Now, of course, one way you might think to do this naively is to say, well, just throw away any information that could taint your process with some elements of these features you're worried about. Like, don't eliminate any information about race or gender. Of course, it doesn't really work, because there's so many other factors that are sort of so tightly wound up with these basic demographic characteristics that you can't just say, I'll remove those explicit features and hope for the best. You have to keep them in, but still have some way of measuring the way in which bias happens. And so there are different measures in which people have tried to do. One way is to say, well, if two people look very similar, then they should have similar outcomes. That seems a very reasonable procedural way to define fairness. What similar means, of course, is a matter of contention. One way is to say, look, and this is what happens, for example, in hiring practices, that what you don't want to see is that the success rate for one group is significantly worse than the success rate for a different group. Right? So in the case of hiring, you might say, I don't want the hiring success rate for, let's say, African Americans to be different from the hiring success rate for Caucasians. Right? This is bound up with disparate impact law doctrine in US law. You might have different notions. This is called demographic parity. You might have a notion that says, well, I may not be able to actually enforce that, but I want to make sure that when I make errors, I don't want to have errors be systematically worse for one group than for the other. I don't want to have one group constantly have false negatives for a melanoma test, so I don't call them back for checking. This is not a hypothetical example. One deep learning system that was used to look at images of scars on people's skin was systematically not working as well for dark-skinned individuals than it was for light-skinned individuals, because it was only trained on one group. And so you don't want a system that makes more errors in one group just because it was trained badly. And so that's another way to measure. And there are other ways you can measure different notions of equity or inequity based on what a system is doing. And then, of course, all these different notions use different parts of the input information to try and define this. And so, different notions are more and more precise about how they try to capture different notions of fairness. And people can reasonably disagree on what they want. And that's a good discussion to have in terms of what is important to you in your situation. Now, once you do that, you have an infrastructure question. Well, how do you actually train this? And so there's a lot of research right now, and I've done some of this research on how do you build machine learning systems that take into account these criteria, these fairness criteria. Do you, for example, modify your training data? Do you add constraints when you're learning a model? Do you modify the labels of a model that's already been trained? These are all different valid approaches that people are looking at, and they have different pros and cons. And so there's an active area of research in machine learning right now, how to build better and more fair training systems. Learning systems. As I said, it's not enough merely to build these systems. You want to be able to check how they work. And so for some example of work that's been done on this is work that I've done. This little pink coding will tell you stuff about things I've been working on. Can you, for example, if I build a system that's trying to predict whether someone should be given a loan, what I'd like to say is, okay, I don't know how the system is working. It's a black box. I threw a bunch of data at the system and it's giving these predictions. What information does the system appear to be using, which is most relevant to the outcome? And you can say, well, in this case, it seemed like we were using this information about their location. And then you might think, well, I don't know if I want location to be the most important feature. Maybe I should go back and tweak the model and change something I do about it. So I don't downweight the effect of location, because I don't want to sort of reinforce sort of segregation, sort of economic segregation patterns by sort of giving people loans based on where they're located. Right? Or I might say it's odd that in this data set, the place they went to college appears to have an influence on whether they're hired or not. This is, again, not a hypothetical story. Amazon was trying to build a system for doing internal hiring predictions. And for some reason, the system was focusing a lot on the school, the college the person went to, which might not seem so odd. But it turned out what it was doing was noticing that the college was a well-known women's college, and it was effectively discriminating against women in the way it was predicting who should be hired. Now, they didn't actually deploy the system. They discovered this. But having tools like this allows you to debug these systems and say, okay, there's something wrong going on here. I need to know what's going on. The problem, of course, is that this is a cat and mouse game. The minute you design systems that can detect whether a system is relying on features that it shouldn't, there are ways that adversaries can design models that hide their behavior. And so this is interesting work. So there's a whole sort of security aspect of this, where once we say we can try to determine whether a model is doing something bad, someone designs a model that hides the fact that it's doing something bad. And now we have to keep playing this game again. There's been work, for example, on how, if you had internal access to a way an organization works, can you build checklists and auditing sort of systems to make sure that what they're proposing to their organizational values are aligned with the implementation they have, so that the technology does in fact reflect the values that the organization wants. I talk a lot about values, but what does it mean to map the values you care about into a specification for a system? So some work that I've done is sort of pointing out that if we define different mathematical definition of fairness, they implicitly reflect certain beliefs about the world and the way we collect data about the world. If we, for example, build a system that says, we are going to look at the outcome of a predictive model, and if the outcome of the prediction, whether someone should be hired, is significantly different between, say, men and women, that's a problem. Well, why is it a problem? It's a problem because it starts from a value that we don't believe that for this particular job, men and women are differently qualified, that they're equally qualified. And so any outcome should look similar, as long as we make sure we have the right population of people to sort of work with. There are some jobs for which this may not be the case. If you have a job that, for example, requires much more upper body strength, there's a sort of, you could make the argument, and I'm not making that argument right now, but you could make the argument that for certain jobs that require heavy upper body strength, men are more suited than women for that job. And that's why even in the law, when you talk about disparate impact, you talk about discrimination, there's a whole process by which you can argue that for the particular job that you're looking for, it makes sense to have that there is a difference in outcomes because of the nature of the job. But this, more broadly speaking, values that we hold about the world and about the data we collect influence the choice of functions we use, and this has to be made explicit. And that's some work we did. There's been other work that I've done working with philosophers, trying to think of the philosophical foundation for new notions of fairness. Some of these notions of fairness come from the computer science community. Oh, this is a function, we can optimize it, looks great. But then you say, well, what value is it actually capturing, and why are we using this function? And that's also an important discussion to have. And again, there's been a lot of work by others also looking at specific aspects of the machine learning development pipeline and how those implicitly are value laden. And again, this is not a discussion that we've had a lot of in computer science. There's been some work from the early 90s sort of pointing this out, that computer systems carry values within them. But it's something that we haven't talked about maybe as much as we should have, and we're doing this now, which is kind of an interesting interdisciplinary reflection on our field. I talked about society and modeling. I talked about how we think about the landscape of society. I've done some work on thinking about what it means to stereotype people, right? So we talk about stereotyping in media, we talk about stereotyping in films, we talk about stereotyping in text. This is a problem because, as we remember, our systems use data to train. Where is the data coming from? It's coming from society. So if we take biased data and put it into our systems, we cannot expect to get anything except a biased outcome in our model. And it's not the model's fault. The data coming into it is biased. But what does it mean for the data coming in to be biased? We have to be able to quantify what it means to have skew in representation of individuals. One example we looked at was stereotyping. Can we encode cultural representation biases mathematically? A lot of interesting work in this area has been thinking about how, for example, critical race theory and how we think about race should be brought into the discussion of how we build machine learning systems. It's not just an attribute or a feature in a vector describing an individual. It's much, much more than that. And the same thing is true for things like gender, for things that are socially laden constructs. And that's a whole very interesting discussion around how we must change the way we think about data representations to reflect this. There's also an issue of, like I mentioned, legal frameworks and policy. There's a sort of some very nice work from many years ago looking at what it means to think about the disparate impact doctrine in hiring, or even notions of affirmative action or relaxed notion of affirmative action in the context of big data. One of my earliest works on this topic was actually trying to think about how we certify whether a system has disparate impact or not, and how you might try to remove it from a machine learning system. People have, especially now with a lot of the issues with disinformation and misinformation around the pandemic, around elections, or other things, there's a question of how to regulate and not regulate social media. How do you create trust in social media? What are the right policy levers we should use? Facebook created a new oversight board. Is that a reasonable solution to this problem? These are both tech questions and not tech questions. They're at this nexus of technology and policy, which makes them, again, very fascinating, but also very new kinds of questions to think about. And so that brings us back to this whole larger picture. And I want to bring this picture back in, because if I show you now where the works of research that I talked about just now live, they all live between these things. And so these boxes, the work that I describe, it reflects interactions between these different notions, between societies, systems, auditing, legal frameworks, values, reflective processes, and so on. And like I said, any kind of interdisciplinary work is both very exciting and very challenging. It's challenging because of the way you have to understand different disciplines. Exciting because all kinds of new questions come up that you never thought about before that are very relevant to the world we live in. That's the real point here. And so that's sort of the end of the second part of what I want to talk about. Oh, good. So actually, before I stop there, I see some questions. So first question, who decides what is fair? How do we account or hold ourselves accountable for biases? It's an excellent question. Right now, and this is the scary part of it, the person who's deciding what is fair is the data scientist sitting in their office at 3 a.m. after having drunk a lot of Mountain Dew. I'm not pointing fingers at anyone except myself here, who's writing some code and making some choice for how to implement a feature. That's how fairness is being decided, because this is the level at which often the effect of the machine learning system on the outcome happens. Some random choice of feature. We don't want that. We want the discussion of what is fair and what is reasonable to happen where it should happen, in the public sphere, where people, the informed public, the experts, the people who are responsible for legislation, for governing, can have that open discussion. And so a lot of the work we do is both exposing where sort of these choices get made, exposing the implication of those choices, and having that open discussion to say, this is how we have articulated our values. Now we can go and implement something that is consistent with our values. Now, how we decide that is a much broader policy discussion. It's a more values discussion that happens at society. It shouldn't happen in a piece of code. And that's the main point. The second question was, can you speak to the issue of persuasion? The type of information AI makes available to different segments of the public may have fairness implications. Absolutely true. In fact, what we're seeing, unfortunately, with news around the pandemic is that because there is political polarization of various kinds that happens around, because everything is refracted through the lens of politics, especially in election year, even information that one might argue should have widespread value to the entire population is being segmented around political systems. And when you have systems like Facebook and Twitter and other social media platforms that use algorithms that are based on what is most likely to cause excitement or engagement, what that tends to do is focus on things that are controversial, things that are extreme, and highlight those things, versus focusing on the large majority of relevant but boring, within quotes, information that doesn't generate the same amount of engagement. And that's a very big question that many researchers are working on right now. We have faculty at the School of Computing who think about the problems of social media and the challenges of information transmission through social media, especially in time of a crisis like right now. So this is a big question. I don't have the answer to this, but it's something that researchers are thinking about right now. How do we think about both the mechanics of how we build better systems for doing news propagation, and how do we think about how our values must interact with those systems as well? Thanks for those questions. Those are great. So let me move on to the third part of what I want to talk about. I'm a researcher, but I'm a professor, and I teach my students, and I hope to sort of teach the, subsequent generation of students to be more aware. To be honest, a lot of the problems we face right now with algorithms is not that people are doing things that are deliberately bad. It's just that they're not fully aware of the complications associated with system design. Because as computer scientists, we haven't really been trained to think more broadly about the role of our technology in society. So how should we teach our students? Well, I think one thing has become very clear is that data scientists need ethics training. So there's been a series of articles about this. Do we need to teach ethics and empathy to data scientists? How do we build ethics education in data science? Mozilla, in fact, put out a challenge for how to, with great code comes great responsibility, how to teach students to think about responsibility in the work they do. They put together this program to sort of, with a bunch of different partners at different universities, I'm one of them, trying to design curriculum that we can put into computer science classes, like your regular programming classes or your advanced algorithms classes and other classes like that. And so for the last couple of years now, and in various forms, I've been teaching a class in ethics and data science. I'd like to say a little bit about what that class looks like, right? So this is the pitch. So we'll explore the moral, social, and ethical ramifications of choices we make at different stages of data analysis pipeline. And we want to understand the basics of ethical thinking, understand the history of ethical dilemmas in scientific work, and study the challenges associated with ethics in data science. And there are many, many classes like this now that are coming up all across the country. I'm particularly proud that we're doing this at Utah. I think it's sort of something that's not many, while different places are doing this, I feel like what we're doing here in the computer science department is kind of nice and is in many ways, I wouldn't say unique, but is definitely one of the few that's really thinking about this at this level right now. So, and what do we teach there? Well, the first thing we have to teach is a sense of, and by the way, this is work I'm doing jointly with the philosophy department. I don't claim to understand how to teach ethics myself. I've worked with philosophy, I've worked with grad students philosophy. We built this class together to sort of make sure we can teach something that makes sense for both of our departments. And broadly, what we want to understand is, what is the difference between responsibility and blame and how that influences ethical thinking? You might be responsible for something, but you may not be blamed for that happening, right? So for example, if Tesla's autopilot system has a crash, yes, the people the engineers who design the system are responsible for it, but assigning blame is a different story in itself, and that needs more care. And that distinction between responsibility and blame, and what moral responsibility and causal responsibility is something that is, as data scientists, we haven't really thought about ever, and that it's important that we teach students that they do have a role to play in the choices they make, that we have agency and power to make choices that have consequences. And that's the point that we try to make. And we have to also teach our students that there are choices at our disposal when we design systems for data analysis, and that we should be consistent. We should be able to formulate and articulate actionable outcomes that are consistent with an ethical analysis of a task. We can't cherry pick, to choose whatever ethics we want to choose at each stage of the designs process. A part of this is what I call epistemic validity. Especially in machine learning, we tend to assume that when we learn from data, we know things. Do we? Well, data science is an attempt to derive knowledge from data, and then it's important to ask ourselves, what kind of knowledge do we derive? Have we derived it in ways that are accurate, that are valid? And do we use it in ways consistent with what the knowledge is? The knowledge may be telling us some things. We might be using it in a way that's not meant to be used. A classic example of this is that machine learning systems are predictive. They will predict an output from an input, which fundamentally means they find correlations. And I'm sure, as you heard a gazillion times, the fact that we can identify correlation between two things doesn't mean that one causes the other, which means that if we now intervene in a system, just because we are able to predict that, let's say, high school GPA is correlated with success in college, it doesn't mean that if we intervene by deciding to admit people to college based on high school GPA, that we are getting correct outcome. And that distinction between the knowledge we can get and what it gives us versus how we use it is very, very important. And it's something that is sadly not talked about enough in the world of data science. The issue of empowerment, one of the things that often, when I talk to students, especially in computer science, they feel, they feel depressed and helpless. Right? And I have this feeling myself, so I know what it means. They feel like, oh my God, this is terrible. We're doing all these terrible things, but we have no power. We can't do anything. There's nothing we can do about this. We're just one person, one tiny cog in a large machine. What can we do? I think we have to realize that, first of all of this has happened before. It's not like this is the first time we've had to worry about ethical issues associated with scientific developments. We can go back to the history of phrenology. We can go back to the horrific, issues with medical testing, the tragedy of the Tuskegee experiment, and we can look at of the Nuremberg, what happened in World War II. We have many, many examples of how science has maybe gone beyond where it should have gone. It is being misused in many ways, and that we had to put in checks and balances to make sure this never happened again. We don't have to reinvent the wheel. So a bit of a history lesson actually is very helpful, as I've found, to students, to make them realize they're not alone. There is things we've learned how to do, and we can do them. And so understanding the mechanisms, both individual and collective, by which we can place checks and safeguards on how we use data is very helpful, because it concretizes specific things we can do today, as opposed to just saying everything is terrible. And that's very important. And this sort of taps into this larger question of moral distress, right? How do we handle helplessness in the face of hierarchy and power? Again, not a question that computer scientists have typically had to deal with, but that they are confronted with when we first talk about this, and we have to then deal with this. So how should we teach them? Most ethics classes build on a foundation of ethical frameworks. They talk about virtue ethics, deontological ethics, consequentialism, or you can just go watch all 4 seasons of The Good Place, which is an awesome show that talks about all these things as well. But of course, that's not enough. You can't use quantum physics to build a bridge. And so you can't use the foundation of ethical frameworks to think about ethics and data science, even though it is a foundation you need to have. So not only do you need the foundation, you need to have an applied ethics for data science, kind of like we have with business ethics, public health ethics, and bioethics. Can we ground this discussion? And can we root it in the way we think about the data analysis pipeline, where we collect data, we analyze data, and we look at outcomes? And emphasize to students that the choices they make in the design of the pipeline have moral consequences they have to be aware of. And so this gets into all kinds of interesting questions. For example, when you collect data, we have this problem of abstraction, where we collect data from a domain. We use statistics and computer science to do this, but the data processing we use is disconnected from the domain. We sort of don't think about the domain at all. We don't think about the fact that data collected for one purpose might be used for another. It's very hard to reason about whether data should be used or not. So one emphasis here is that when we're collecting data, we need to understand where the data is coming from and what the context of the data is. We can't just pretend that someone threw it over the fence at us and we can just work with abstract data. That's unfortunately how CS classes are taught, but that's not how we can do it. How we can teach machine learning and other data science classes if we want to have more respect for the data and how it's being used. We should think about, another question that came up. Most of today's AI is machine learning or deep learning, as I view as expert systems. Are you aware of any actual intelligent type systems in development, those that learn beyond the ML data sets? Deep learning is definitely the dominant buzzword. It's not the only buzzword, but you're right that much of deep learning, much of learning we do in AI is machine learning. There are variations. There's things called reinforcement learning, where systems adapt to their environment. Think of your Roomba, or think of a game playing system like plays Go or chess. They adapt to their environment. So they're still machine learning, but they're more general in a sense. There are also systems that people are looking at which are called causal systems, that are actually trying to explicitly learn causal frameworks to reason about data and do interventions. But everything is very much a data-rich environment, so machine learning has become the dominant paradigm. There's a lot of tensions within AI between what are called more symbolic approaches that look at sort of thinking about a domain very deeply and trying to build systems that can reason logically or infer logically in that domain versus data-driven systems. Most systems are some kind of hybrid with an emphasis on the data side of things. Thanks for the question. So I was talking about data metaphors. One thing that's very interesting is that how we think about data changes our ethical compass. Do we think of data as a natural resource, like often companies like to think about it? It's like oil, it's like wind power. Do we want to think of it like data like personal property, which gets into issues of privacy? Do we want to think of data like public good, like the contact tracing we want to do right now to trace people being infected in the pandemic? Do we want to think of data as hazardous material? Like, for example, the breaches in, say, Experian or Wells Fargo, where personal data is being breached, and now the breach has caused harm, just the way with hazardous material it is. Do we want to think of data as things we share with each other, as a gift? Do we want to think of data as a form of self-expression, identity? How we think about data and how we unpack the way we relate to data actually changes the kinds of ethical issues that come up and how we should think about it. We also think about power relationships. Who controls the data? Who's asking the questions? Whose data is being used and who benefits? This, if you're familiar with some of the Belmont principles of doing work in ethical sort of science, this relates to the issue of justice, right? Are we making sure that the benefits are spread to the people who are actually being subjected to the testing? This comes up a lot in criminal justice, for example. The courts, the prosecutors, the defendants, the public are all stakeholders in this decision. And you can't ignore them if you want to think about this. Having thought about how we collect data and how we think about power relationship and other structural relationships in data, we also want to think about data analysis. How, this is more of an epistemic inquiry. How do we decide which features we include? What encoding do we use? How do we normalize features? What happens when you throw in everything you can get? When you get an answer, what does it mean to have an explanation? What's a scientific explanation? How do we go back to the theory of scientific explanations, for example, all the way back to Aristotle and what they give us, right? Do the explanations give us what we need to take action? Because machine learning systems, especially deep learning systems, are very inscrutable, how do we generate explanations post facto? Can you make them more explainable? Can we say that we only want to use systems that are simple enough to be explained from the very beginning? These are all technical questions as well as larger policy questions that we have to ask ourselves. And should we even use systems at all? Sometimes the question is maybe no technology is better than one. And that's something as a technologist I tend not to ask, but sometimes has to be asked. And that's an important question. Should maybe no tech is better in this case rather than trying to do something? We have to think about what happens when we deploy the tools, right? Well, there are different dimensions of harm that can come from deploying a tool. There are sort of temporal issues of justice, both in time and in place. Issues of distributed harm versus individualized harm. I might get some benefit, but that society as a whole might not. When I get personalized recommendations from Facebook, maybe I'm happy with my newsfeed, but overall what this is doing is causing the news recommendations to be governed by what's engaging and what rather than what's true, and that may be a bad thing for society as a whole. We have to think about how the way in which we deploy a system has an effect on the world, which then feeds back into the next iteration of the system. And these feedback loops can cause their own problems. We have to think about secondary use and how a system deployed for one purpose might be misused for another purpose, and that would be a bad thing. We have to be able to learn to start thinking about this more critically. One of the researchers in this area who works at University of Colorado designed this very nice class activity. If you're familiar with the Netflix TV show called Black Mirror, it's about sort of a dystopian view of modern tech. And one exercise I did in my class was to have people imagine sort of a Black Mirror episode's topic based on some technology hook. Think of how it could go badly, but also conversely, in a white mirror version, think of how it could do well. And so just as an exercise in writing a script for a TV show, students get to imagine how a technology could play out in good ways and bad. And of course, we have to think about the role of society at large and how we are playing a role in this. We're seeing a lot of concerns about, the 2020s be the decade of eugenics. Again, this is pre-pandemic. I think post-pandemic we'll have other concerns as well. We have issues of what IRBs actually look like in the age of data. We've seen, companies that do body cameras build ethics boards. We've seen companies that do technology build ethics boards, doing it badly like Google did, or doing it with oversight boards like Facebook is trying to do. Professional organizations in computer science and now have codes of ethics and professional conduct. The IEEE, which is another organization, does the same thing. So we're seeing a lot of discussion around both the need for more responsible use of data science. We're seeing the unpacking of the research questions around this. And we're seeing how this connects up with society in ways that require us to talk beyond just our own field, talk with other disciplines who have spent a lot of time thinking about these issues in society at large, which is very exciting as well. And with that, I will conclude. Thank you all for listening, and I'd love to take any questions that you might have. So one question, a comment that has come up is the issue of using AI in the context of health. It's actually quite an interesting topic. It's not something I personally have spent a lot of time studying, but I think I have actually, so I was at a conference last year where I had to speak on this issue. So let me illustrate some of the questions. And there are folks at the U who are thinking about this as well now. So here's one set of questions, and I briefly alluded to this. We're designing a lot of systems now that use AI technology, especially in radiology, where you can think of a machine learning system analyzing an MRI scan, analyzing an X-ray, let's say trying to use data from MRI scans to classify a brain scan as maybe showing early signs of Alzheimer's, for example. In fact, it's surprising how far you can get with simple systems. I had a high school student from West High working with me for a science fair project, and he was actually within a few weeks able to build a system with some trained data that could do a pretty good job of predicting, compared to ground truth data, whether an image scan was showing sort of signs of early onset Alzheimer's, for example. That was quite, and so there's a lot you can do with these systems. However, like most things, these systems are trained on data, and often the data that they get come from whatever data is available, and that tends to reflect, again, who's going to the hospital, who has the resources to go and get scans, and there are biases in them. So one concern is about demographic biases of various kind, that the systems being trained are going to be very good at predicting outcomes for one group, one population, but not another. That's a problem. Doctors' notes, actual text, are often converted through natural language processing into more structured information to be, again, mined for more predictions. Even there, the use of choice of words has been research showing that when, for example, there's a difference between how doctors might write notes based on whether a woman is expressing concerns with chest pain versus a man, whether it'll be described as sort of anxiety versus sort of a potential heart disease. This is again of concern, especially if you have automated systems now processing this in doctors' notes. That's one dimension. Another dimension is, and I'm starting to work with colleagues of mine who work in human-computer interaction and also in the area of disabilities. What about people with disabilities, folks with disabilities who need assistive technologies? How do we make sure we build technologies that are reflective of their needs and are not only catering to sort of, some of the more, let's say, well-known disabilities, especially people who don't have visible disabilities, but have motor issues. Sometimes their needs are not addressed by some of the larger sort of systems to help, say, with assisted sort of vision or with hearing and so on. What do we do about that? So there's a lot of questions circling around the issues of AI and ML. And one question that came up is sort of privacy, right? So what happened? There's a big attention here, because in order to do a better job with technology, we need more data. In order to figure out whether people are spreading the COVID-19, we need to do contact tracing. How do we balance the concerns for privacy along with the concerns for equity and public health that we need? And these are, I don't have any good answers, but these are tensions that come up where the design choices and who gets access to data and how it gets used are ways to protect against some of the misuse of data. One other comment came up. Can you tell us about any real-life examples of investigating the MLM model to prove fairness? Yes, I can. So one of the most famous examples of this comes up in criminal justice. So like I mentioned, in various states across the country, jurisdictions are using tools to predict, for example, will someone reoffend if we release them on bail? Or will they reoffend after they've done a term of their sentence if they're released? Setting aside the issues, the larger moral, social issues around whether the system should exist for now. Okay, setting aside that, the question is, if you then build a system, what is it doing? Well, it's you're using some prior data, it's trying to build some predictive model. And ProPublica went around and investigated the way these systems are working and discovered that, in fact, they had huge biases, racial biases. This was in Florida. They were essentially much more likely to erroneously declare African-American inmates as high risk compared to white inmates with similar sets of other features in terms of crimes committed and history of criminal activity. So that's already an example of that. Another example, there were police. We talk about police jurisdictions using predictive policing tools to predict where crime might be happening. And yeah, I'm not making this up. This is not sci-fi. This is really what's happening across the country. And there again, it was found that a lot of these systems, they were being biased because and this is where the feedback loop issue comes in. The data used to feed into the model to predict where crime might happen tomorrow was based on where police were sent today, as the model told them to, which causes feedback loops where basically all the efforts concentrated in certain areas, which turned out were minority heavy areas. A question came up: how do you effectively police organizations that are blatantly using algorithms unethically? This is challenging. It's a mix of essentially threats, legal threats, regulation, policy, public shaming, and activism by people inside the organization. This is what we've seen with Facebook, where we had researchers who identified problems with Facebook's ad targeting system, that it was allowing, that it was basically providing interfaces where landlords who want to do illegal ads for housing, which are not supposed to discriminate, but they were allowed to do that with the interface, and they had to come under a consent decree and had to sort of change the way they build their systems. So that was a legal approach. There's a lot of public shaming. Google had to pull out of certain contracts for building artificial drone systems because of internal activism from their employees. There's a lot of journalistic work. A lot of the work around risk assessment now is informed by that ProPublica study I told you, where journalists went and exposed problems with how these systems are being used. And now anyone who's using risk assessment has to be a lot more careful because they're worried about some of these issues coming to light again. So it's a combination of things. One question that came up is, how do you motivate data scientists and instructors to recognize ethical issues? This is what my class tries to do. We work through a number of cases. I do very little lecturing in the class. Most of our lectures are cases where we look at cases. And sadly, it's very easy for me to literally wake up in the morning, look at Twitter and say, okay, this is today's case for the class, because every day there's something or the other going on. And oftentimes I won't tell the students it's a real story. I'll tell them and they'll tell me, no, that's just bizarre. That could have never happened. And I tell them, well, actually, it's happening right now, and they all get depressed. So this has been the story of this entire class. But yes, case studies are very, very important to help people understand how to see these ethical issues. And the goal is not to have an answer for every question necessarily, is to come up with the right framing to interrogate these issues, to sort of break them down and say, okay, these are the main concerns here, and then come up with a best case scenario based on what the constraints are, right? We're not going to have a single cookie cutter answer for all problems, but we have to be able to recognize where the issues are going to come from. And in fact, I would say maybe 70% of the issues we have with bad deployment technology would have gone away if people had just been more aware. There wasn't necessarily bad intent, but there was ignorance and sometimes deliberate ignorance. So the last question: what do you see the implications and growth of AI from organizations and countries that have inbuilt biases being used around the world? This is a very good question. For example, in natural language processing, most of the work being done, and the very good work being done in language handling, the fact that you can, talk into your phone and have it do searches for you, is because everyone studies English. What about all the countries where English is not the dominant language? What happens to those places? How do we encourage people to work on what I call low resource languages, languages that are not as popular? I mean, there's something like 7,000 different languages in the world, but very, very few of them actually have the richness of study that English has. Even if you look at something like Wikipedia, there's many, many more articles in Wikipedia in English than are in French or German or Chinese or in Hindi or big languages like that. And moreover, the way we talk about things like race and gender are very different in the US and the way we talk about them in Europe, the way we talk about them in China or in India and other places. The EU, for example, has this thing called the GDPR, the General Data Protection Regulation, that are all kinds of guidelines of how to work with data. This is not true in the US. The way interaction between government and private entities work in China is very different to the way it works in the EU. The way we talk about data collection in India is very different to the way we talk about data collection here. There's a lot of work going on in these places, and that's, I think, very important that we have a global sort of family of researchers working on this. I cannot speak to many of these questions, even questions of values, right? A lot of the values we talk about are very Western values. If you talk about values coming from things like Hinduism and from Buddhism, you get a very different way of thinking about core ethical standpoints that look very different to the way we think about ethics in the US. How do you build systems that reflect those ethics as well? These are all, again, very fascinating questions. I think that these are great questions. I'm really glad that you asked them all. And again, it just shows how much more we have to learn, how much more we have to figure out, and how these things really, truly are going to affect the way we build the society of the future. And with that, I think I'll conclude. Thank you all for your time. I really enjoyed talking to you, and I hope I hope to sort of convey some of the excitement and all the interest around campus at the University of Utah and broadly across the country and across the world about this very new direction in computing and society. Thank you all.